All right. Our last topic that we're going to be looking at in this section is the complex numbers. Is last for this module, I guess. And is the complex numbers. Complex numbers, and just, I guess these are the outcomes that we're going to be looking at. So we'll talk imaginary numbers, add, subtract, multiply, and divide them. That's down in here, and look at this stuff called I. We'll be looking at that in a second. But complex numbers really belong in this section where we've been talking about radicals, because what a complex number is, notice here, well, what a complex number is, I think I have a definition here, is a number that can be written in this form, a plus bi. Now this I, the letter I, is a special letter in math, and it arises whenever you take the square root, here's our radical, of a negative number. So far, if we've had something like this where we've said the square root of negative 16, we've said, hey, you can't do that. And under the real number system, you can't. But under the complex number systems, you can. And you can deal with, we'll show in a sec how you can get that. We'll deal with how you can work with negative numbers under the square root. So back to this diagram just for a second. What we've been dealing with so far are all of these number systems here. The real numbers include irrationals or radicals. There's other numbers that are irrational that aren't radicals, like pi and e is another example. But often they're known as the irrational numbers if they're square roots. Rational numbers, so fractions and integers and natural numbers, all of those belong under the real numbers. Well, if I include numbers that have a square root of a negative number, -4 or 5 or whatever the number is, if I have the square root of a negative number, then those things are called complex numbers. And so the complex numbers then will include these things called imaginary numbers, like the square root of -5. It's not something that I can see or I can plot on a number line. But complex numbers include those imaginaries, and it also includes all of the real numbers. So it's basically a larger number system than real numbers. So it includes all the numbers we've seen before, but it also lets us attack and deal with the situation that arises when I have a negative number under a square root. Okay, so how do you deal with a negative number under a square root? This is how we do it. We say, and sort of it's an imaginary kind of thing, that if I ever have the square root of a negative number, specifically -1, I can replace that whole thing with the number I. Okay, so I can replace this whole thing with an I. Also, if you square both sides, use that principle of powers, if I square this side, I come up with a -1. Square this side, I come up with an I squared. So also, anytime I see an I squared, I can replace that with a -1. So the two things that we'll be looking at is if I have the square root of a negative number, like this, I can replace that with just a plain I. Or if I see an I squared, I can replace that with -1. Those are the two critical things that we need to be able to do as we proceed through adding, subtracting, multiplying, dividing complex numbers. Okay, so let's try it with this one. I want to rewrite this in an I form. Square root of -4 under the real number system doesn't work. But under the complex numbers, I can work with that. Square root of -4 is the same thing as the square root of -1 times the square root of 4. The square root of -1 we saw on the other page was equal to I. So I can replace this with a simple I. And the square root of 4 I know is 2. And so the square root of -4 I can actually rewrite as I times 2, or usually we write it the other way, and we'll write it as 2i. Okay, square root of negative 4 is 2i. Let's try this one. Here I've got a negative under the square root, so I can work with that. Let me see. I've got a negative out front. We'll just leave that. And the negative 12 I'm going to change to negative 1 times by the square root of a positive 12. And I do that so I can isolate this and use this little trick up here. So the square root of negative 1 is actually I. And now I've got the square root of 12 there. So my answer to this question or simplification would be a negative root 12i. Typically we put the I at the end. Make sure it's not under the square root sign. It's always outside there. Oh, 12, I guess I could rewrite that again, couldn't I? Because 12 is the same thing as the square root of 4 times the square root of 3. And the square root of 4 is 2. So this would be minus 2 root 3i. Okay, simplification of that one. Now, if I'm adding complex numbers, the first thing I need to do is make sure that they're in the I form. These ones are in the I form, so we're okay. But if there was a square root with a negative number underneath it, I'd first have to make sure that I put it in the I form first. These ones are already in the I form, and what you do is you treat the I just as you would any other variable. So if I'm adding these, 2 plus 8, that's 10. 5i minus 3i, it'd be a plus 2i. Done. So I treat them sort of as I would any other variable. When I have a negative in front of a bracket, I know I've got to be wary of that. I need to change the sign of each thing inside, so it'd be a minus 8 and a plus 3i. Adding again, 2 take away 8 would be a negative 6. 5i plus 3i would be plus 8i. So that would be the simplification of that subtraction of complex numbers. Maybe if you want, pause and take a shot at some questions in your book where you're adding and subtracting complex numbers. When you're ready, hit play again and we'll go on to others. If I'm multiplying complex numbers, one thing that I have to do, similarly to what I did in adding and subtracting, is I first have to get any negative radicand, that should be a D, I needed to get it into the I form first. So just doing something like I did here, square root of minus 2 times square root of minus 10, with real numbers, I could just multiply the two radicands together. In this case, minus 2 times minus 10 is a positive 20. But under the complex numbers, that rule does not work. I first have to convert these to the I form. So this one, root of negative 2 would be the square root of negative 1 times the square root of 2. Square root of negative 10 would be the square root of negative 1 times the square root of 10. Hopefully you're getting the idea here. Square root of negative 1 is an I. So this first one I'd have root 2i. And the next one I'd have root 10i. Now multiplying those, there's no add or subtract in there, so I'm just multiplying. Root 2 times root 10 does indeed give me root 20, but I times I is I squared. And from that other page we said anytime you see an I squared, I could replace it with a negative 1. And so at this point the I squared becomes negative 1, and just to be clean I would write that at the first. So it'd be negative 1 times the square root of 20, or negative root 20. So notice the difference there. A key thing is make sure you change them into I form first and then proceed with multiplication. Okay, let's try this one. Well, maybe you can try this one on your own. I won't go and solve it, but I'd need to make this an I, make this an I, and then I'd go and do the FOIL between those and simplify if I could. All right, just as in radicals and square roots, I cannot have a radical on the bottom of a fraction. Same thing applies when we're looking at complex numbers. If I see an I on the bottom of a fraction like this, I shudder and say, you can't have an I on the bottom. Similarly to, you can't have a radical on the bottom. Or, if I have a 2/4, I have to simplify that. So if I see an I on the bottom of a fraction, I need to get rid of it. And similarly to working with radicals, the rules of getting rid of them are the same. If I have one term on the bottom, I'm going to take and say I need to get rid of this I, so I'm going to multiply the bottom by I, and I'll multiply the top by I. Multiplying and doing this, 5 times I would just be 5I. On the bottom, 3I times I would be 3I squared. Oh, but I squared I can rewrite. So this would be 5I over I squared is -1. So it'd be 3 times -1. Or I could write it as 5I over -3. Again, like any fraction, the negative could be on the bottom or on the top. I could put that up there if I wanted to. It would be the same thing. Okay, so thou shalt not have an I on the bottom. Sometimes you might have a binomial on the bottom that includes an I. And similarly to what we did in um, radicals, what I need to do is take both the top and the bottom and multiply it by the conjugate of this. Do you remember what the conjugate was? Conjugate of this is I just changed the middle sign, so it'd be 3 plus I. If I do that on the bottom, remember that factor of 1, I need to do the exact thing on the top. So in simplifying, 14 times that would be 42 plus 14I would be on the top. And on the bottom, I'm going to have to FOIL. 3 times 3 is 9. 3 times I would be a plus 3I. Minus I times 3 is a minus 3I. See what's going to happen there? Minus I times I is a minus I squared. Bit of simplifying, can't do a whole lot on the top there. I'll just leave it as 42 plus 14I. However, on the bottom, 3I minus 3I cancels, so that's 9 minus. And we said I squared, I can always replace as -1. So I have 42 plus 14I over 9 plus 1, or 10. Now I'm feeling pretty good there, but I notice that each of these have a factor of 2, so I should maybe clean that up. I can factor a 2 out of the top, leaving me with 21 plus 7I, and I can also rewrite 10 as a product of 2 times 5. Here I have a factor of 1. I can simplify that out. I can cancel that out. So my answer, totally simplified, would be 21 plus 7I over 5. Notice no I on the bottom there. So hopefully that has led you through an introduction to complex numbers. We've learned how to add and subtract them, multiply them, and we've also learned that having an I on the bottom is against the law. You've got to get rid of it. And whether you multiply it by the same term or if you multiply it by the conjugate, whichever way, you need to get rid of the I on the bottom. All right, go try some questions.